Hmm. Yes.
Oh yeah,
Which one is ionic
sorry.
compound? Hmm?
Yeah,
See the
I told you
conductivity.
what's
Hmm.
yeah, what's it called? What's it has to be T.
Okay. Sorry, we were on this part number three. Which one is a gas at room temperature? You have to tell me the gas.
Oh, gas at
Hmm.
room temperature. Uh,
Hmm. Gas.
is it F? Because if you see what's it called, like the melting and boiling points, boiling point is -6. It's below room temperature.
Sorry, can you hear me?
Yes, yes. Is it F because the what's it called? No, the boiling point is -6 degrees. It's below room
Yes,
temperature.
yes, exactly, exactly. That's why. Okay, good. Which two substances are liquid? Which substances are liquid at room temperature?
Liquid at room temperature, it's C and E,
Why?
because melting points is below 25 and boiling points are above 25. So
Hmm.
it's below room temperature, but the boiling points is above room temperature.
Yeah, and they are melting at uh, negative temperatures, right? They have mentioned the
Yeah.
negative -5 to 1 to -1, and then, yeah, boiling. Okay, okay. One substance is a metal?
I wrote A because it's a good conductor. It's a
Yes, it
good
is a.
conductor at room
Hmm.
temperature.
And you know its melting point is 961. Among these all, the highest one
It's
is
the
this.
highest.
Yeah, and the boiling one is also highest. That's why. Okay, good. Which one is an impure substance? Yeah.
Uh, I wasn't sure, but then I wrote E because what's it called? Like the melting and boiling points are like different temperatures.
Sorry, what you are saying?
I wrote E because
Yes, yes, you are right.
yeah,
That's
because the
why.
melting and
Hmm.
boiling point are different
Yeah,
temperatures.
they are not sharp. When we talk about something like ionic or covalent, we know that they have sharp melting and boiling points. Just like the water, the boiling point of water is 100 degrees Celsius, and that is fixed. 100 degree. It will boil at 100 degree. It will not boil at 99 or at 101. That is a fixed value. Okay, we say that in this case, whenever you have a pure substance always have fixed melting and boiling points. Okay, their value,
Mm-hmm,
you can say a sharp, not fixed, a sharp value. But in the impure substances, there is a range of temperature, right?
mm-hmm. Yes.
Okay, good. Give the name of the process that occur when a gas turns into liquid. Yes, gas turns into liquid.
Give
Hmm?
me 1 minute. I'll be back. Just give me 1 minute. I'll be back.
Okay, okay. Yeah, okay. So there was give the name of the process that occurs when a gas turns into liquid. Yes. What is this?
Um,
A
when
gas.
a gas turns
Hmm.
condensation.
Yeah, this is condensation reaction. And what about when a liquid turns into gas? What's that?
Liquid turns into gas. That's
Hmm.
boiling.
Yeah, that's boiling. Okay, next, give the name of the process that occurs when a solid turns into gas without forming a liquid
I
directly.
wasn't sure about
Yeah,
this.
this is known as sublimation.
I thought it
Like,
was evaporation,
no, no,
but
this is sublimation. For example, you have ice, okay, and that
mhm,
ice directly convert into gaseous vapors without converting into liquid. That will be known as sublimation. Okay,
mhm,
direct conversion, like from gas to solid or from solid to gas. This is sublimation process, right?
mhm.
Okay. Figure
Okay.
1.2 shows a colored crystal cobalt chloride. This one is cobalt chloride. Okay. It placed at the bottom of a beaker. After 2 days, the color has spread through the water. Yeah. You see, this was, it is a colored crystal of the cobalt chloride. After 2 hours, there is a few, you can see the whole liquid is not converted into colored. But after 2 days, this whole liquid becomes colored. Why is this so?
Mhm. Because like when the particles in the like it will dissolve in the water, the particles of the crystals will dissolve, and like the substance of like the chloride, the particles and the water will like move
They will spread
randomly.
out.
So the
Yeah.
yeah,
Which
the
process
mixture
is this?
will like diffusion.
Yeah, this is diffusion process, right?
Yes,
So, once,
because it goes from
mm,
high concentration to lower concentration until
yes,
like it's fully mixed.
yeah, the this diffusion will occur until the particles are distributed evenly. Okay, uniform. There is a
Evenly.
yeah. Okay, complete the table 1.1 about solids, liquids, and gases. Yeah, this one. This is very easy. Yeah, we have
Yeah,
done.
the
Mm.
first one is solid,
The
like
particles,
no, no, close together. It's close
the
together.
particles are very close together, right? Okay, what about the second liquid particle arrangement?
It's like random.
Yeah, they are random and you can say irregular arrangement is there,
Hmm.
right? Irregular. What about the third one, gases? They have asked for the type of
Random,
motion. No, type of motion.
random.
Yeah.
Yeah,
Ra-
random.
yeah, random motion. And this is rapid random motion,
Hmm.
right? Okay, the graph shows the change in the temperature of a sample as a sample of the gas is cooled. Now, what they are saying, the gas is cooled. So now you have to tell what is happening but from A to B.
What's it called? From A to B, it's gonna be condensation
Why?
because it takes a bit of time to become like it goes from a gas. So
Hmm.
when the gas like it stops for a bit, it becomes gas to solid.
Yeah. There is a point this in which you can say this during this time the temperature remain constant. Why? Because the energy is being released. Okay, energy will be released
Yes.
because the gas has to be cooled. Gas
Hmm.
is cooling, it means gas is converting into liquid. Okay, so if a gas is converting into liquid, it means bond will be formed, right? In liquid,
Yeah.
the molecules are closer as compared to the gas. So when molecules are closer to each other, wait a minute, I can explain you this. For example, the molecules are initially like this, okay? But when they are going to be cooled, it means there should be a bonding, right? There is a bonding because they are converting into liquid, right? So this is the time when these bonds are forming, okay? Are you getting this?
Hmm.
This is the time, during this time, the temperature will remain constant, okay? And why it will be constant? Because at this time the energy is being released to form these bonds, okay, to convert this gas into liquid, right?
Yeah.
Okay, name the change of state taking place between, okay, this is condensation. A bottom of the liquid perfume is left open at the front of a room. After some time, the perfume is smelled at the back of the room. Name the two physical processes taking place.
So diffusion, because it goes from high concentration to lower, so it spreads across the room evenly, and evaporation, because
Why?
the gas particle.
Hmm.
Yeah, because what's it called? An evaporation, like where the it's basically the liquid perfume will become in a gas.
Hmm. Basically, the liquid is enclosed in a container, right? In the perfume bottle.
Yes.
So that liquid is escaping the bottle. Okay, that liquid is escaping from the
Yes.
bottle in the form of vapors. So this is known as
Vapor.
evaporation, right? Because
Mhm. Yeah.
it is the particles are firstly the liquid is converting into gas, and in the form of gas it is being spread out. So this is
Hmm.
evaporation, and the spreadness of the particles is diffusion.
Yeah.
Okay. This question is about bromine and compounds of bromine. Use the kinetic particular model to describe the arrangement and type of motion. Liquid bromine and the bromine gas. Yeah, what's the difference?
The differences between because bromine is liquid, like between the different
Liquid
parts, like
bromine and
it's a
bromine
liquid
gas.
and gas.
First, tell me about
Yeah,
liquid bromine.
liquid bromine is basically like the particles are closely packed together.
Hmm.
The arrangement is random, and it has a random movement as well.
Yeah, random movement. What about the gas?
Gas, its particles are very far apart, a random movement and rapid movement, and
Hmm.
it's randomly arranged.
Yes, exactly. Okay. The next question is about the graph shows how the volume of bromine gas changes with the temperature. The pressure is kept constant. Describe how the volume of bromine gas changes with temperature.
It changes because what's it called? Like when the temperature increases,
Hmm.
you see the volume of the bromine gas will increase as well.
Yes. So this is the answer from here. This is by these points you can easily detect what is happening. This is there is a direct relation between volume and temperature.